Okay, I already have this this bin, but this is for I have this tool installed before. But as you can see, we have that the Kubernetes version is 2.1, and we have access to the kubectl. But we need to configure the access to the cluster. So you have to do, sorry, you have to go to this step and but change the name here. I'm going to copy this thing, but not copying the name. So I'm going to puzzle this, and I'm going to go here to another, to here, and I'm going to copy this. If you have here, this is okay. So I'm going to paste it here. So with this command, we're going to give the needed credentials to kubectl to access our cluster. So with that, okay, I have it. So let's check that we can access to the nodes. So I puzzle here with this, you should see 3 nodes, 1, 2, and 3. This is the 3 machines we created before. So I think that is quite desirable is to install the metrics server. This the metrics servers will give us metrics about CPU, RAM, and disk of the nodes and the pods, so we can see if some pod or some node is overloaded. So this thing is quite easy to install, and this will be really helpful in a Kubernetes environment. So I'm going to copy here this, and we're going to puzzle this. So that this won't be immediately, but it will take a little bit of time. But in the meantime, we're going to deploy the simulation. So we're going to the next step here. And you see the diagram I explained before. I'm going to remove my simulation because I have it already. So RP1 base simulation minus RF, and I'm going to close Docker also. We have a clean slate here. So we're going to clone this repository. So we're going to puzzle this. So, okay, we're going to enter this repository, okay, here. And now we're going to deploy these first time services. So we're going to puzzle this. So, and let's, for example, kubectl get SBC, and you will see that we have, for example, we have a load balancer, and we have a cluster IP. This is kind of services we have in Kubernetes. All the Kubernetes experts will know we're talking about. The others, you have to believe me. So, and after, we're going to deploy the simulation with this command. So, with that, we're going to deploy all the config maps and all the deployments that will create the required pods. So this thing is not instantaneous, so we have to wait a little bit, but we can check what is the status. With this command, you see that, for example, localization is pod initializing, and this is container creation. But for example, the Gazebo client is already in it and is waiting for be ready. If we repeat this, we have another status, And we see that, for example, the localization is running, but it's not ready because some other pods are not up yet, and we have to wait a little bit. I'm going to do a little trick here, is to do a watch in order to have this in loop and see how to the pods are working, they are doing what they are doing. So, for example, Gazebo, they are pod initializing. So we need to check that everything is running and everything is ready. So, for example, we have the ROS master service is ready and running, but the Gazebo server is starting up. So is the pod initializing, maybe it go in a few moments in running. But for example, the Gazebo client is running and is ready. So we are going to wait a little bit, but this.
In the meantime, if I can interrupt you, sorry, Guillaume. Due to we are waiting for the deployments of the simulation, I want just to have do a brief summary of where we are now, so that the people that don't get lost. So the first goal, we said we want to deploy a robotic simulation in clouds. So we want to use Kubernetes and the Amazon Web Service to deploy the robotic simulation using the Kubernetes orchestrator in clouds. So as Guillaume showed until now, in the first steps, we have created all the classes, the virtual machine, the nodes that are all the computational power that we need to run the simulation. Also, as we've seen, the simulation is quite heavy because, use an engine like a Gazebo. There are some nodes, some packages related to the robot. So we need a powerful machine with more CPUs. And right now, where we are now, you are trying to deploying the container that we have created to have a Gazebo simulation of the world and a Gazebo simulation of our robotic base with all the ROS packages related to the navigation localization. This is to have the summary until now, so the people don't get lost.
So if you have any questions, you can ask, and we will happy to. If you have some trouble also with some steps, please let us know. So I think everything is running. So we're going to close the watch. I think that I made a little bit easier for the, a little bit bigger the font, so you don't get. So the next thing we're going to do is, now we have everything running, but we don't have the access to the Gazebo and the Arbit. So we're going to puzzle this here, everything. I'm going to, this command will give us the URL to the, for this one, to the Gazebo website. So if you copy this in your site, so copy, and we're going to go here. Pass. So as you can see, we have a virtual environment. So now we have here the Gazebo client. So we're going to leave it as it is. I'm going to do it the same with the Arbis. I'm going to copy here this and go here, puzzle. So enter, and we have this other URL. I'm going to put in another tab. So here, and we have your interface if you want it. So we have Arbis, we have Gazebo. So for the ones who are not familiar with Gazebo, this is the Gazebo client. So we're going to teach you a little bit how is the basic interaction with that. If you enter here, you will do okay, we have the client here. So with the mouse wheel, you can zoom in and zoom out. And I'm going to zoom out. And if you click on the middle wheel and with the middle click, you can rotate the camera. So the thing here is to try to see our robot. So with the left click, you drag. If you drag it, just click and move, you will move around the wall. So, and with the left click, you can go to the zoom. It's the same that with a wheel. So one thing interesting here is that the real-time factor is that our simulation is almost running in real time. It's like we are a little bit behind, but the time of the simulation is 1 second in the simulation is 1 second and 0.2 on the real world. So we are quite close here. So let's go and see our robot. And you can see, you can do it with the same, and we see this is the RB1 base. We have here the laser rangefinder. This is the 2D LiDAR, and we have the camera. So another thing you can do here is to, if you want it, is to pause the simulation with this button, and you can resume it in order to save a little bit if you want to do something. So this is, and with this afterwards, we can insert some kind of obstacle here, and we can see how to interact with them. So in order to save a little bit of power, do we see the Amazon Web Service energy consumption? I'm going to close this. You can open or leave it open as you want. And we're going to go to the RBIS. The RBIS, as I said before, this is a digital twin. This is a very powerful. Let's go. I'm going to open again so we can see here. This is a very powerful tool. So what are you seeing here? You are seeing the robot. It's going to do a zenithal, a top view here. I'm going to try to put the same angle and we have here. So the robot is more or less, let's check here. Let's go here. So if, well, run button. So if you see here, the robot is here and you can see this 45 angle world. So the robot is around here. So in RBIS, the robot is represented by a 3D model. Now we are in a top view and this is a 3D, but you will see as a red dot, black dot. But you have here the robot representation, that is this thing here. You can put it, you can enable and disable it. So we are seeing the map. This is the map we made from the Willow Garage, using the laser from the robot, and you can see this is the layer. So these red dots are the laser points. So you can see it here. This is the one. You can also, if you enter here, you can check, you can play around with the colors, for example. And these green arrows, this is the pose array. This is the particles of the AMCL. This is the most likely positions we have on that, because this is the first time the robot has a little bit of uncertainty, and that it's not quite sure, the AMCL, where it is. When we start to move, you will see that these particles start to